You can see here is already a network, and in about 10, maybe 20 minutes, I will explain you what this network actually represents. So this is not a random artwork or something created by an AI, but this is an actual data visualization showing some very interesting data set. Okay, for the usual things I've been presenting thousands of times before. Today's topic is going to be bearing the same title as my latest book, Connecting the Dots, which is a book and which is a topic which tells us how widespread network science is in our daily life, which means that there are countless networks all over us, wherever we go, whether we just pick our smartphones, whether we work in a company, whether we engage on social media with anyone, every step we do in these settings, we are becoming parts of various networks. But networks, even though even the word network has become very popular in the digital era, also huge thanks to the social media platforms, network science actually has a lot longer history than that. So a little bit of a history lesson. Network science, and let me just switch on this navigator. Yes, so network science and the historical origins and roots of network science go back nearly 3 centuries to the early 1800s and to a city which is now in today's Russia called Königsberg. As you can see here on the map, hopefully you can see it, there was a river and there is still a river in the city which splits the city into several parts, and these parts are connected by 7 bridges. Hence also the name of this problem, the bridges of Königsberg. So there was a popular puzzle back in the day which said that there is no way to walk around the city in a way that we would pass every single bridge just once. So imagine there's a city, there's a river, and there are 7 bridges. And people started to walk around these bridges one by one, and they realized that there is no way they could make a walk where they pass every bridge just once. So, all right, so this sounds like a very crucial problem for urban planners, transportation engineers. But for everybody else, it doesn't seem to be very relevant because what happens if we can't cross or we have to cross a bridge twice, right? So it doesn't seem like a big deal. So the locals really stuck to this puzzle so heavily that it reached the mayor, and the mayor reached out to Leonhard Euler, one of the biggest mathematicians of his time and probably of all times. And first, Euler discarded the problem because it seemed like something unrelated to mathematics, but for some reason it stuck to him so much that he started to realize that this is actually something that cannot really be handled with the current mathematical tools, but it's something almost ready for the taking for a new branch of mathematics, which was graph theory. So after putting all this together, Euler actually figured out how to prove mathematically why it is impossible to make such a walk across the city. And nowadays it is actually called an Eulerian walk. On the one hand, sad news, it turned out that there is no way to make such a walk in Königsberg. However, good news is that a new branch of mathematics was born. So well, I wish all of you such a nice puzzle and solving a puzzle with such a nice outcome that laying down the foundations of a new scientific field. And by the way, if you happen to visit Königsberg or Kaliningrad today, you will be able to complete the walk because especially during the past century, during all the world wars, there were some unfortunate events as well as rebuilding of old bridges, which ended up Königsberg having either 5 or 8 bridges today. And in either case, now it is possible to make such a walk. So that's how networks and graphs started. And again, this was about 300 years ago. And still, we are using the very same core concepts as Euler had back in the day. So the simple graph structure Euler proposed consists of nodes, these spherical bubbles, and the links or the connections between them. So this is a really, really simple backbone structure. However, they can get extremely complicated depending on the kind of data we fill these networks up with. So also usually in the field of network science, we call an object a graph when it is just nodes connected by links without any real-world data encoded or stored in them. And once we start to fill up these nodes and links with actual data, we will start to talk about networks. But this is not a very strong definition. This is more of a practical or hands-on definition, what we usually do and say on a daily basis. So what kind of data can we fill these nodes and links up with? And that's where the most important or the most pronounced strength of network science come out, because network science is an extremely general, versatile modeling framework, because with network science, we can study nearly any complex systems we can think of. We can study social systems where the nodes are people and they are connected, for example, based on who knows whom or who is working with whom or who is related to whom. So based on all sorts of social relationships. These nodes can also be, for example, animals where the links correspond to the different elements in a food chain. So one node is one species, the other node is another species, and they are connected if one species is feeding on the other. Then we can also talk about networks between, of course, social media profiles. If we are friends with someone on Facebook or we are following someone on Instagram, then again, our profiles are the nodes and they are connected based on friendships and following relationships. Then we can also talk about networks of things, not just living beings and people and the representations of people, but we can also talk about the networks of devices. Just think about the World Wide Web and how our phones, our computers, our iPads, and all our smart devices are connected to the World Wide Web. Or we can even think about, for example, cities as networks, because the transportation, especially the public transportation network, is also a network, just as much as the global or international trade ecosystem, showing which countries are importing and exporting which kinds of goods to which other countries. Or even if we go back to transportation, the global flight and airplane routes or shipping lanes are equally valid or great examples of networks. So we could actually go on with this listing forever. And I have also done a couple of attempts or efforts to collect a whole bunch of networks. Some of them are also wrapped up in my latest book. But today I would like to focus on a few selected stories. And before that, just a few more examples and colorful images. And the main reason I'm bringing so many different examples today is that in this talk, I would like to show you and I would like you to deeply understand how diverse the possible applications of network science is.